I'm curious to hear from you both. What are the challenges for CPUs and the common practices of adding huge amounts of cores?
If you look at the CPU industry, more specifically in CPU performance over the last, let's say, 50 years or so, you may notice that in the 80s, in the 90s, the main key factor for performance was the frequency, and that was going pretty well. So actually the technology helped the CPU design to be better and better, but most of the performance was driven by the technology, and more specifically the frequency at which they operated. In the early 2000s, the technology stopped giving this improvement, and so architects had to start devising new solutions to improve it. And CPU makers started doing the first multi-core CPUs. They were good at first, but after a while, CPU performance reached a kind of plateau in terms of performance, and so basically in the last, let's say, 20 years, I think the CPU technology hasn't evolved so much. It left room for other devices like GPUs and like application-specific chips to take advantage of it.
Yeah, I guess the standard solution nowadays add more and more CPU cores to one system. So using those and adding more threads often just causes more time to spend in synchronizing, and also cache coherence upkeeping is requiring more and more time.
Martti, how do you think Flow can help?
PPU is designed for parallel processing from the very beginning. It addresses the theoretical requirements of efficient parallel computation, say latency, synchronization, bandwidth, programmability, and also the cache coherency that is part of these. And it addresses those with new architecture and methodology that is specifically designed for parallel computation.